is this methodology actually? What and how it can be used to your benefit, especially if you want to conduct, and especially if you have time series data. And time series data, later on I'll give numbers of example. What is actually time series data? How actually it can apply into real world and how it reflect the real world itself. Because that's what we want in the end of the day. We hope to have the data itself, and then you do a little bit of analysis, and then after that you produce something research so that it can be presented or perhaps can be shared with others, and it can also be used as an important policy implication for the country, for the district, for the place that you are living in, and so on and so on. So this has been the time series have been used a lot, especially in economic studies, at least from my point of view. And I'm usually most part of my research I use time series analysis also, right? So this is a bit of the menu for today. I straight away go into perhaps the equation or the understanding and so on, right? And actually I have this is just the introduce to you what is it all about. Hopefully we can I will give some ideas with all of you. And next week where we're going to meet again, next Saturday we're going to meet again, I want to show you actually how we can conduct, or how actually we can do some estimation using some tools around doing some estimation. Mean hands-on, and of course, if you have the program, will be good. If not, also is okay, because it will you can easily download and find the program elsewhere or somewhere else to get this statistical program for you to estimate certain relationship here. All right, so when we start off with what is time series, let me just put this thing up. Okay, right. So when it involves time series, what's mentioned by time series means that you have the elements of time inside there. Means that time plays a factor. When I say time plays a factor, I will give a very simple example of, for example, today. Today is Saturday, 2nd of December, 2023. And when I say time series means that the data reflect time factor. The data reflect time from one period of time to the other period of time. For example, your data is from just made right here, 1960 to 2022. Sorry for this part. It's okay, or I can type. But for example, you have data from 1960 to 2022. So it's about 60 over years the data set. This is called a time series. Okay, so that's the element of the simple understanding of what is actually time series itself, right? Let me just wrap off this thing first. Okay, so time series, again, it goes back to the understanding what again, the elements. Oh, not this one. Okay, this one. All right. Okay, this one will be okay. Right, time series analysis. So normally, if we don't include the time factor, this will be the normal regression. If you can see this type of regression, whether you do cross-sectional data or time series data, or even panel data. But cross-sectional data would involve something like this. Cross-section, of course, means that just that particular moment of time. Like for example, today, the data that we have for today, for example, here, there's 70 of you, excluding me, excluding me, 69 or 68 of you will be the sample actually for that particular, the n equals, for example, 68. This is the particularly the sample that we use for cross-sectional. But in time series, the storyline is different because it plays a role of the time factor, as I told you. So today, for example, today, we can call today as T. We represent today as T. Today is T. Right? Yesterday was T minus 1. That is yesterday. If the data reflect daily itself. If not, T is 2023. If it's a yearly data, T is 2023. T minus 1 is 2022. And of course, if we have T minus 2, right? For example, you have T minus 2, then it's 2021 and so on and so on. That's the reflection and understanding of what is time series in this sense of what is this equation all about? What is this T minus 1, T minus 2? In that particular understanding and regard. So this is the prelude, or this is the basic of what is time series. So time factor plays, or time series data means that it include time factor, which play an important role in part of the estimation and determining the relationship between one variable and the other variable. In this case, means that the time factor plays an important role. So what happened yesterday will be an important information for today, and whatever happens today will be an important information for tomorrow. If your data is daily data, right? One of the best, another example that I'll give would be on weather, right? The weather that we see today. Perhaps here in Malaysia, here is sunny out there right now. It's sunny behind me. Beyond my window here is sunny day. And the prediction, perhaps, or the forward looking, they use the information what time series been doing, or the simple usage of time series data or time series information or analysis is that they use the data of yesterday or 1 hour before or 6 hours before to predict or to use to forecast the weather for now and perhaps few hours down the road and so on. Of course, we can see that easily in our smartphone today. In our handphone today, we have apps called weather to check on the weather forecast. So that simple understanding will give back to what is actually time series analysis is all about. So what we're trying to do here, what I'm trying to bring you, the picture here is that we're going to use that type of analogy, weather forecasting or weather prediction, that adopt into different sets of different data sets. Perhaps, time series data, for example, like GDP, for example, like export, import, interest rate, and money supply, and all the other inflation, unemployment, and whatnot. Those are basic macroeconomics data. And all this actually can be, with a proper modeling, with a proper model and proper methodology, of course, along the way, we can predict what's going to happen. That's what always happen. That's what the government, any government, or maybe government agencies are trying to do, to predict some way to the future, what's going to happen in 2024, 2025, and so on and so on, or for the next quarter, with the necessary information that we have right now. I hope I give that a very brief understanding and background before we dive into much deeper parts of what I'm going through here. All right. Is it okay for everyone? Can I move on?
Yes, Professor.
Thank you. Thank you for the response, Hilmer. And yeah, you can always respond in the chat if you have anything else, like I mentioned to you. Let me just put this thing off first, right? Okay. So that's the understanding, the basic understanding of what time series are, and then of course, one of the best example would be using weather itself, weather forecasting, right? Don't have to go far, because weather is what we see today. It's what you always seen, and if everyone check their apps in their phone on weather to see okay, what's the weather for tomorrow, prediction, right? It says that in my phone here, raining is expected at 4 p.m. at 4 in this afternoon. 20% of raining and at 5 is 20% also in my phone. You can check yours and see what is it all about. Now my location here says that it's 32 Celsius. A bit cloudy out there, but it seems like sunny out there rather than cloudy as predicted by my the phone here. Right, so that is a kind of information, but how they get this information? How they get this information? This information was gathered, of course, using data that they have, right? Real data that they have, perhaps the data of the weather that they use to do this simple analysis inside the weather apps and all our application. For that to do a simple forecasting, what's going to happen the next hour and so on, as I mentioned to you. And all these are what I call as what I understand as this is time series data. Previous information was used to predict the moment right now. And the moment right now will be used as an important information for tomorrow and tomorrow or the next hour or so in this case. So in this case, this is previous information because you have T minus 1. T minus 1 means that lag of one period. One period of time can be a year ago, can be a quarter ago, a half month ago, 2 weeks ago, and so on and so on, 1 day ago, 1 hour ago, depending on the data and time series data that you have. So the understanding is that from that perspective, this is the time series understanding. If you have T minus 2, means that is 2 period before. Today is T, yesterday is T minus 1, 2 days ago is T minus 2, and so on and so on. Right? Let me just proceed. I hope it gives some idea what is it all about. Okay, so if you have, of course, you have anything, please do not just stop me so that I can explain what did not understand on this part. Right, so of course, if we dive into econometric theory, there's a revolution, of course, especially from 1970s onward. This is a bit historical that I'm going to tell you a story, and then so that we dive in. What's the relevant? Why is the relevant of using all this methodology that's around? In 1970, normally the econometrician or the economic studies normally use different sets of model. When I say different sets of model, in earlier days in 70s, of course, we use this one simple model like this. Let me just type better in that sense. Let me just put this thing back. All right. I think it'll be good here. Okay. Yeah. Normally, this is what happens, right? You have alpha there as a constant. You have you can write as A plus bx plus an error term. And error term can represent as E. So this is the common equation. Blue in color. Okay. I hope you can see that part. It's okay. I want to bring this thing forward. All right. Yeah. Okay. Yeah, I found a way. All right. So again, this is what normally we've seen in the in most of the literature, right? This simple equation that happens in 1970, or we call it ordinary least square. If you do primary data also, you also deal with ordinary least square or relationship. You want to test relationship between x and y, x1 and y, x2, x3, x4, x5, x6, all those independent variable and the dependent variable, of course. And this idea have been brought forward also, same thing, into economics analysis, of course, time series analysis. So this is a simple regression that been used 1970s onwards, especially until today, of course. But there's a revolution, there is a improvement from just testing like this, but go beyond this testing into a much better methodology represented, so that and all those variable, all those model that been tested, of course, will be much representative in that particular sense, right? So the development is there, or what we call as time series econometrics analysis. And one of the issues that they look into is non-stationarity. What is non-stationarity? This is something that I'm going to mention. Let me just clear this thing first, so that you can go to the next slide. Okay. All right. So particularly, I want to introduce this person before we dive in again into the much of the later part. This particular person called Cliff Granger, which is responsible of what, especially for time series analysis, I just read TS, time series econometrics or time series modeling in economics data. If you use time series data, these are one of the major person that have been accredited to Cliff Granger. He of course written a lot on time series analysis of forecasting, the theoretical statistical theory, and we use that. If we involve in time series analysis, this is the pioneer behind of the understanding of non-stationarity, co-integration, and of course the next few methodology that are connected in that sense. So and he won the Nobel Prize in 2003, which is 20 years ago, with Robert Engel. These are the and why I did not show Robert Engel, because Robert Engel because Engel here Robert Engel contribution are much later part rather than Granger, because Granger itself have been there since 1970s, developing this idea on how to understand how to test the variable. So before his time, all models are just tested as what we understand. We put in our data, we estimate the regression, and that's it, and explain. Not now, not after Granger put his idea, especially after 1974 onwards, because he bring to the world of economic research by saying that we should understand each variable first before we put up in the model. Before we model it up, the X and Y, the IV and the DV, the independent variable and the dependent. Before doing that, we have to understand each of the variable, the characteristic of each of the variable. It's like another analogy that normally I'll give is like you have to get to know the person first before you deciding to marry the person or to go ahead with that understanding, right? You have to know the person and before we move forward to another decision, right? To another stage. So same thing here. I put that back here, is that you have to know, we have to know the variable first before we put up in the model to test the relationship between X and Y and all these variable that you want to test. All right, and that's the idea behind Cliff Granger. Of course, this is one of the his Nobel lecture. Nobel lecture happens in 2003, December 8th. There's nearly about 20 years back, actually, 20 years back, and talk about time series analysis, co-integration, application, and all those available. And he changed this other person, as I told you, Cliff Granger, changed the whole understanding of econometrics then. Not just 20 years ago. He won the Nobel Prize in 20 years ago, but he developed this idea in late 70s or mid 70s up to early 80s. No, up to mid 80s actually. It's about 10 years developed the idea from 1974, and then he have an important article in 1981 and then 1987. So these are the timeline where he developed. And of course, after that, there's a lot improvement and innovation from his basic idea. That's why he won the Nobel Prize itself with Robert Engel itself. And These have been updated. Of course, just again go back to the history, but I'll tell you what is actually non-stationarity. Why we need to test that. Why we need to understand each variable first before we proceed, as been mentioned. As I mentioned just now, Granger and Newbold, Granger in mid-70s, and then this is all important article. And then after that, in the 80s, the development becoming different, especially for time series understanding or time series analysis. Right, so let me bring you this picture itself. What is mean by stationary and non-stationary? If you look at this variable, if we plot a time series variable, normally this is what happened in the time series variable, right? Time series variable have one characteristic, which is trend. We have trend inside there. One of the characteristic of time series data is trend. TREND. The trend can be upward, downward, or perhaps fluctuate like this part, and then it goes up again or goes down again. So you have a trend. That is time series data characteristic. Time series data characteristic, right? So if you have this type of upward trend, downward trend, which if you understand in economics theory, like demand curve, supply curve, all have a types of trend. Is that supply curve is upward sloping, and then demand curve is like downward sloping. This is just an example, but it's a lot more other variables, of course, in economics have trend. Basically all the variables in economics are actually having that kind of understanding. Yes. Any question? You want to ask anything? No? All right. Proceed. And this is an example. Just now, as I said just now, having a trend upwards, downwards, and so on is what we call as non-stationary. Non-stationary means that they are not at one line stationary, or they are not fluctuate around the mean from the understanding of statistical point of view. And this is the example of stationary. Stationary, if you see here, compared to the previous slide, previous picture, is that one is going upward, one is just fluctuating around a mean. There's a mean there. There's a on average there's a mean. If I draw this line, zero line here, can see that actually the blue line actually fluctuate around this zero line, which what we call in statistic as a mean. If this is understanding as a mean, then this fluctuate around the mean. This is example of stationary series. Another good example of stationary, actually, another good example of stationary, another good example of stationary would be our own heartbeat, our own heartbeat. Heartbeat itself, which every one of us having a heartbeat, right? Our heartbeat, by theory, by your understanding, hopefully you understand that part. By understanding of our heartbeat itself, our heartbeat not supposed to look something like this, right? Correct or not? Am I do you think your heartbeat looks something like this or like this?
Like that, sir.
The second one, this one, rather than like this. If your heartbeat looks something like, if your heartbeat have a trend, of course our heart, if your heartbeat having a trend like this, then perhaps it's time to go for check your heart itself, right? Our heartbeat supposedly to be quite stable and consistent in that sense, right? But perhaps at this particular time, which is a bit like this or a bit like this, if this is a heartbeat, perhaps this is the time, maybe it's a resting time, sleeping time, not fluctuating so much, and this is the time where you fluctuate up much. Perhaps you go on some activities, running, or doing some other activities that requires our heartbeat to pump in more, or and so on. So, right? So I hope that bring the idea. Stationary is like our heartbeat. Stationary is like our heartbeat. Non-stationary would be going up, upwards or downwards, and so on, like the previous graph itself, right? So it means that heartbeat supposedly to be something like this, right? Looking into my own heartbeat right now, my heartbeat right now, according to my watch, is 73. My heartbeat right now 73, 72, 71, somewhere there. So I'm quite relaxed actually, sitting down here, speaking, talking to every one of you, and perhaps much relaxed in that sense, rather than having this one. If I having this one, I have to go and see my doctor itself, and ask what is happened, what's wrong with me, if this is the heartbeat itself. So the understanding is that, again, this is non-stationary, this is stationary, and most of the time, most of the variable in economics, if you plot the graph, it will look something like this rather than like this, except if you take growth data. If you take the growth types of data, growth rate, if you take growth, I just write GR, growth rate data, it will look something like this. But if you take the nominal data itself, for example, you take GDP, rather than GDP growth, then it looks something like this. If you take GDP growth, if you plot, perhaps it looks something like this. You can try. You can try and take the data and plot. Yeah, this is a be good exercise for all of you to understand the theoretical understanding behind and what are the application. And we are concerned, especially this idea or time series analysis is coming from Granger up to the more latest one. They're still dealing with this, is that we have to understand each variable characteristic first, whether they are stationary or non-stationary, for us to decide what's the method that, or what's the relationship, what types of model that is suitable for this type of data. So if you use growth data, then you might use a different, little bit different method. If you use the non-stationary data, like for example here, then it will be different in that particular regards. This is just an example of a GDP of Malaysia in nominal terms. This is the example of a residual in the regression itself, which looks fluctuating around a mean itself, right? I hope I bring you that idea, non-stationary and stationary. And of course, as I mentioned just now, this person, Cliff Granger, responsible to bringing in all this theory and idea, which have been adopted more than 40 years as of now, right? 40 years, nearly 50 years down the road of this development and revolution since the 70s until today, right? And formally, their most famous article together, Engel and Granger, was published in 1987. Of course, the idea was briefly explored by Granger itself earlier on in the 70s, as I told you, mid 70s, early 80s, and mid 80s itself. All right, so this a bit of the history. You can read through, you can Google through what is the history of co-integration test, how they use it, how they argue that despite that having the variable having non-stationary again means that if you plot the graph, the variable will look something like this, or the variable maybe look something then and then go down and then like this. So having a trend up and down and so on. So this is the type of trend rather than having types of variable which is like this. If it's like this, you can draw a straight line. It seems to be fluctuating around that mean or threshold. There's a threshold up and below threshold for the variable to fluctuate around. So that's the understanding. of course, the first thing that I want to tell you for the past at least 15-20 minutes or so is that we must, Granger and the colleagues says that we must understand each variable characteristic first before we put them in the model. So this is to understand what are they, how could we use them, and so on. Let me just put this thing off and then, okay. Right, so like for example, like this now I bring in another concept inside there, which is co-integration. Just now is non-stationary, now it's co-integration, which is very much linked together. Very much linked together. So co-integration means that two or more variables move together in the long run. Why is called long run? Because the concept itself is adopted into our economics theory itself called long run. In economics, normally we are looking forward into long run rather than short run. But of course, this depending on which school of thoughts that you've been which school of thoughts that you follow. But generally, we understand in economics of what we call as a long run, especially long run equilibrium. We are very much fascinating in economics. We're very much fascinating of this, finding this equilibrium, for example, despite that this might be finding this equilibrium. And this concept can be adopted here. So this blue line and the red line here, not this graph, this blue and the red line here, going forward, going up, have a trend. Right? These two variable or three variable, if you plot them together, it seems like they move together. They have a aim, a similar aim, the same aim going forward. That's what this graph looks like. So this simple concept brought forward in 1981 by Granger, Cliff Granger itself, says that this is what we call as moving together is what we call as co-integration, right? The concept of co-integration, how co-integration come into the economic studies and becoming permanent here, becoming something that everyone will test if you look into the literature, right? So that's the simple concept itself. Again, as been explained here, if long-run equilibrium relationship exists between a sets of variables, those variables are said to be co-integrated. Co-integration. So another analogy normally I will give. Another analogy normally I'll give will be related to what all of you are today. Despite this is conducted through online, through Zoom, all of you here, right? Perhaps to learn to know more, to explore more. So that's the aim, the same aim. So everyone coming together here today to learn something, and of course with the hope that can be put into you some ideas, and then you move forward and bring this to the real life practicality. Of course, that's first the aim itself. And of course, the other aim of all of you here in this room right now is to graduate. Just to graduate. But in order to graduate, you have to go through all this process, this class, the assignments and whatnot related to that before you go into graduation. So graduation day is everyone aim. How you get there is another story. But graduation is everyone aim. Everyone have a similar aim, graduation. And that's what Granger can call it as co-integration. Because everyone moving in the same direction towards that graduation, but perhaps doing in their own way. Right? And so on and so on. So that's the analogy of co-integration, right? This is the reading. You can read, of course, you can read through. It says that for equilibrium, for long run relationship to exist, the variable can be non-stationary, but the variable can be non-stationary, but they have something that binds them together. What is that something? As I told you just now, graduation. in your case, graduation is something that binds all of you here. This class, for example, is what binds all of you together coming into this class. This part is conducting online. And those aim, the bigger aim was graduation. So all of you come together as one, and all of you are co-integrated, or the concept of co-integration. That's the concept, a simple concept of co-integration. How being used? There's another different, of course, is another storyline. Let me see. Okay, right. As I already mentioned just now, the concept was firstly developed by Granger, and then further elaborated by Engel and Granger, and all those people after that, Engel and Hughes, Stock and Watson, Johansson, and all those ideas behind of co-integration. So it has been explored. This is only the linear part. If you go for the non-linear part, there's another different branch. So the expansion and extension and revolution is widely. And of course, this is one of the biggest reasons why these two persons called Engel, Robert Engel, Cliff Granger, won the Nobel Prize because of their vast application, not just in economics, but in other fields too. The idea is simple. As long you have time series data, you can do this analysis. Of course, we have a minimum sample size. That's another second issue. But as long you use time series data, you can use this. For example, you want to do something related to the firm, perhaps firm performance. It sounds finance, but if you want to look into the performance or some other issues in the firm, if the firm have exist 20 years or more than 20 years, means that they had the data for more than 20 years or about 20 years of data. So this data is translated, is what I call as time series, and be adopted as a time series analysis, and you can use this methodology as long as it fulfill the criteria time series. But if you collect the data through questionnaire, or through interview, if you do qualitative, then it's a different sets of story. This is quantitative, but time series. The data is time series, not cross section. So that's the I hope you bring that idea. And this is just from theoretical point of view. What is econometric? What is co-integration? Not econometric. Sorry. What is co-integration? It says that if I read through the slide, it says that time series X and Y are said to be co-integrated in order of such a thing. If there is a linear combination of such variable between X and Y, so they are co-integrated. They are co-integrated in that sense. And with that, they can move forward what to do next. So first, just now, the first step just now was check whether the data is stationary, non-stationary. Understand each characteristic, and only after that, this is what happened, then we put them into a model. We estimate them, we got the result, and we conclude, do they have long run relationship or just a short run relationship? Can find it there, can decide there, and that will be important application through your projects and through your if you have the time series data, of course. All right, let me move forward here. So the concept is there, stationary, non-stationary, and then after that to co-integration. Now we move forward to another concept which also been awarded Nobel Prize. It's what we call as vector autoregression. Vector autoregression by Christopher Sims. This guy, Christopher Sims, in 1980, he bring up this idea, but they won the Nobel Prize, I think, in 2011. They means that two person won the Nobel Prize, like Engel and Granger. This one is Thomas Sargent and Christopher Sims that won Nobel Prize back in 1980. Pretty sure that all of you have not born yet, except for myself. right? So in the 70s, before this method come into picture, this is what normally we do, and we still do it in such a way. The only difference is that right now we use VAR, for example. Right, we use VAR, we use co-integration, we use the stationary, non-stationary test, or what we call as a unit root test itself. So VAR offers a very promising solution for what all those econometrician or forecasting model have not been able to do so before 1980. At the same time, when this developed, at the same time also, just now, Engel and Granger was, or Granger is also been developed, or I mean around that time. So everything come out around that time, and it's still relevant, especially in economic studies until today, right? So let me just rub this through. Of course, you have any question, you want me to stop anyway, please do so. As I told you, these are the two person behind, especially Christopher Sim, the second one. Thomas Sargent also very much related to macroeconomics. Christopher Sim is a pure statistician and econometrician. Won the Nobel Prize 2011. And the idea was brought forward in 1980. Only after so many years, 1980, about 30 years, 31 years after only they got the Nobel Prize. So of course, I always tell this to anyone is that you want to get the Nobel Prize, you must live long. You must be live long enough, because Nobel Prize only be given to those who are still alive. You must live longer. But of course, if you join the education, perhaps you can live longer as a professor and whatnot. So if you develop your theory now, right now, and 30 years down the road, 20 years down the road, a lot of people use it, adopt it, apply it into practicality, real world scenario. That's where you have a chance to win the Nobel Prize. This is especially in academic, not the one Nobel Prize of Peace. Nobel Prize Peace is different criteria, a little bit different criteria. The rest of it, we have chemical, we have medicine, we have physics, chemistry. Nobel Prize in chemistry, Nobel Prize in medicine, Nobel Prize in literature, Nobel Prize in physics, economics, and then peace, if I'm not mistaken. These are the only one that we have. So in economics, if all of you here economics itself, then actually economics itself have the Nobel Prize every year, right? Every year. This year was won by this year was let me recall back. It's okay, I'll tell you when I recall it back. This year was normally the announcement was on October, and then they will have the lecture in December. This is what happened itself. Anyhow, coming back to this picture first, Christopher Sim, of course, VAR, he brought forward what the world know as what is VAR today. Of course, VAR is built from AR itself. So what is AR? AR is autoregressive. The first equation that I show you just now, y equals to, I just write here, alpha plus, sorry for that, beta x plus, let's say you have yt minus 1 plus an error term. This yt minus 1, which have the element inside there, is already called as an AR model, autoregressive model. So plus a v in front, vector would means that it's like estimating inside the matrix form, using a matrix form that we understand in economics. That's the I mean the matrix form itself. Okay, let me put it. Let me just rub off here. So VAR is just a simple application, but then was a very of course a very innovative innovation at that particular time, right? Until today actually. So what is VAR? You can easily find this on the web. What is VAR? It's a workhouse multivariate time series model that relate current observation of the variable with past observation of itself and past observation of other variable in the system. So in the system, this is called vector. So you don't estimate one equation by itself. If you do equation, if you estimate one equation by itself, we call it single equation or single single equation itself, which can be easily called as AR model. But if you do that in the vector, then it's called VAR, vector autoregression. So that's the beauty. That's what Christopher Sim have developed and shared it with the world. And of course, he won the Nobel Prize with the another friend called Thomas Sargent. Right. So what VAR can use, especially forecasting, structural analysis, and it can be used for important policy analysis. Important policy analysis. So the application is wide, vast. A lot of policymakers also use VAR to understand the time series, and after that, to know what to do next. Forecasting again, as I told you, right? The main idea behind of why I need to do all these things. Why I need to understand all this. With the real data, you will be more appreciating of what I'm saying here. For example, who use VAR? These are all the people can use VAR. Why use VAR? Policy analysis, structural inferences, forecasting for description. It been used in finance, economy studies, and all the others also. Like for example, I give this example. They will also use in medicine, biology, and all the other related field, economics, macroeconomics, business too, as I mentioned just now, as long the data is there. As long the data, the time series data is there, means that you have the proper time series data from one period of time to the other period of time. Then we use them. This is just an example of some of the research paper available. If I easily Google them, you can find it out, right? These are example of it. Vector autoregression model, Granger causality in time series in nursing research. Nursing research, dynamic change among the vital sign. Prior to, this example of respiratory instability events as an example. Heart, cardio, right? In that particular understanding. So but this one very much related to the study actually very much related to the heart rate. Is mentioned here, the heart rate, respi, and then the how it linked to stress. I guess this is what the article is all about. I do not read the full article, but look into. Interestingly, they adopt this model. Not just in economic studies, and not specifically, not exclusively for economic studies. It can apply to others. As long as the data is there. Right? Let me just rub this thing off and move forward. Okay. Where is it? Where is it? Okay. All right. Okay. These are the few articles. These are the few articles. So I tried to download them. Another one appeared here. Risk interaction and coronavirus infection across age group after the peak of the COVID-19 epidemic. And then they use data. If you find that they use daily data, as I told you just now, it can be used daily data. And then multivariate vector autoregression and whatnot, they estimating. This is for the case of COVID-19. Right, COVID-19, of course, if it's seen through since end of 2019 up to today, or at least up to end of last year, 2022, have of course affected a lot of things, affected the economy, the social economics, the people, society like you and me and everyone else. And there's a lot, still plenty of research that talking about this, the impact of it. And of course, the data is available daily. Means that if you collect the data, you can get 4 years, perhaps 4 years of daily data. The sample is huge. As you might understand, 1 year you have at least 300, you have 365 observation times 4. This is how big your sample size. And you can look at it part of the time series data. So, right, let me just clear this thing. And then we move forward to another one. This one also in biology, modeling gene expression regulatory network with sparse VAR model. Right? They use this model to understand, to promote, or to understand the relationship between these variables itself. Gene expression regulatory network itself. Okay, I hope you get more idea behind the adoption, the application itself. Okay, this one paper that I written some years back, published some years back. This was appeared in 2019. Sorry, not 2019. It's longer than that. 2017 perhaps. Yeah. Although it was online since 2016, but 2017 only it appeared officially. Another issue that we look into, me and my co-authors, we look into suicide and socioeconomic determinant in Canada beyond morality and philosophy. Means that how we use VAR model with the data that we have on suicide that we try to establish a meaningful relationship between the variables. And then after that, we do simple forecasting or simple forecasting using causality test, and another test that we use in this research paper also. All right, so these are some of the adoption, right? Not just exclusively for economics data itself. Yeah, like this one, why I show you this, because this is about suicide. Can we actually understand what type of variable impact suicide, and some of the socioeconomics variable that is available. This can be adopted into any country if the data is there, not just this one. Any types of researches. Another research of mine that this one was published 2019 by me and one of my students on border trade, on trading, export and import, using a simple gravity model between the place that I'm in right now, in the Borneo Island. I'm in the Borneo Island here in Sarawak. The northern part will be Sabah, and the southern part sharing the same island with us, 3 countries in the same island with us, which is we have Brunei there, and we have Indonesia, which is what we call as West Kalimantan. So three countries in one island of Borneo, and we are part of it. Sarawak, and then you have Borneo up the north. In the middle, you have Brunei. Miri is there, and then of course at the same time at the south is whole West Kalimantan, not just West Kalimantan, the whole Kalimantan. West will be on towards nearer towards Sarawak side itself, is West Kalimantan itself. So we also use VAR model estimating to prove that border trade is actually very famous and important economics activity to spur the economy, of course. And of course, the second part is also to have that with the family. To explore on the societal well-being itself. Although it's not a focus on the paper, but then again, we prove that the border trade actually promote more of income win-win situation from both sides. And all the other materials that have been promoted at the same time. This is just an article itself. And I already explained just now what is VAR. This is just the notes itself. For example, like this. So I told you just now, if we divided them into equation, it will look something like this, 2 equation. But we transform them into matrix form like this, which is called VAR. Then this is called VAR. And When this is called VAR means that this is what we are going to do. The VAR, rather than looking into this, rather than looking into the equations separately, one by one, we estimate them together at the same time. Right? So that's the understanding of VAR here. Okay. Any questions so far? Anything? Hope you understand. I bring the three big concepts here. Let me bring back. Just now, the first one was about stationary. I just write NS here, stationary and non-stationary. The second one was about co-integration. The third one is about VAR. These are the main thing I want to mention to you and have been adopted in the literature, so much of literature. Let me grab off this thing. Okay. Right. Same thing here. I got this from the World Wide Web. If you have three equation, two equation, one equation, you develop them, you estimate them together, then we call it VAR. If we do it separately, we call it AR only. Right? Vector autoregression model. The other expansion, this one article in journal called Econometrics, the article called A Conversation with Soren Johansson. Who is Soren Johansson here? Who is this guy? Soren Johansson is actually, he and the wife, Katarina Juselius, developed of what we understand today is a Johansson and Juselius co-integration test. So this is from, again, original was from Granger, but then they developed further from the innovation, and is widely adopted in the literature of economic studies, especially, and all the other related studies which use time series data. Okay, so this part of it are rather important. So let me go ahead with the slide. Okay, so this idea of what we call as a multivariate co-integration test, or JJ test, actually was built upon the understanding of VAR, right? VAR come first. VAR historically, VAR. Let me just put it this way. Better in this way. VAR. 1980. JJ 1988, and 1990. Okay, so historically VAR come first and JJ come later, means that Johansson Juselius was developed after VAR was published. So they built their model based on the VAR rather than using the earlier idea of rather than using the method called Engel and Granger, or in short, it's called EG, Engel. 1987. Oh, sorry. Right. It's somewhere around there. But then again, Johansson Juselius improved that to include the idea of VAR inside there. Engel Granger do not use that. Engel Granger is a basic one. Basic. It's like we use our smartphone. What's the basic model? And what's the additional features that you want to add? So all of these are additional features. in 20, 30 years back. But now becoming a norm to apply. Right? You have a basic phone, or you want to have a phone with camera, a better zooming, and so on and so on and so on. We leave that, right? There's a different sets of understanding of how this thing come about. Just rub this thing off. Okay. And yeah. Inside Johansson Juselius test, actually we have two different statistics to answer whether What's the use of Johansson-Euclid? Same thing, the same concept, because this is co-integration. What we want to find, long-run relationship between the variables. This is our aim, to find the long-run relationship between the variables itself. So in that sense, in Johansson and Euclid, we have two different statistics. One is called likelihood ratio, or LR test, normally call it. And the other one is called maximum eigenvalue. No worries about this. No worries about these slides. I mean, about the equation here. I'm trying to give you a different sets of understanding, explaining, so that you're not relying just on the equation. Equation-wise, you can read it through, not the, and so on. When I say statistic, means that to do Johansson-Euclid, you need, of course, data. And then after that, you need to test. And in this testing, they offer two statistics, two sub-statistics. Sub-statistic to understand, or to answer the question of whether our variable actually are co-integrated or not. Are they co-integrated? Are they moving together? That's what we want to test, to know the long-run relationship. And important implication of Johansson-Euclid is that how the result will impact the whole relationship. Oh, this is a important slide itself. This will look very much practical if you have some results later. If you have some estimation result, this will be very, very practical. But then again, here, where you do not be able to see that idea, then perhaps this will be not so suitable yet in this case. But then again, I just bring forward this one, because we're going to do some estimation, not today, perhaps next week, to know that actually how to do them step by step. Okay, all right. Let me try to look at this. All right, thank you. Let me just off this thing. Okay. Another few more of my own article of adopting all this methodology, especially like this one also. I'm doing on crime and economics of crime, especially on social economics, the impact of crime towards the society, the impact of crime towards GDP, towards some other variables. So I use VAR model, a special types of VAR model called VECM, Vector Error Correction Model, which after this I'll get into that, and then after that we're going to finish up this part. And then if any question, please do ask, or anything that you don't understand, still very much. This another topic that I did some years back. This was published in 2019. This was published in 2013, 10 years ago. The topic is hungernomics, explaining food threat sustainability. It's still the same of asking about the question of, do we have enough? Do we import more than our own export? That's the how the difference between export and import. But here we're focusing on the sector, the food sector itself. Right, to tell you the truth, I got the idea of the title called Hungernomics from the selection of movies from Hunger Games. Actually, Hunger Games, I have that idea, Hungernomics, to combine hunger and economics into Hungernomics. Right, actually, if you look into some of my research paper itself, we also developed another terms, or we adopted the terms called criminormetrics. Means that the application of crime and econometrics together, called criminormetrics. Econometrics and crime, combine them, becoming criminormetrics. It's quite acceptable today, right? And of course this one of course look into using this topic. I mean, use the same methodology, just adopted into different sets of data. As I told you just now in the beginning, as long we have time series data, we have the theory to support. We can estimate the relationship. We find what we want as a objective of the study, and then after that, we write it out, and of course it can be shared and published in journals, related materials and whatnot. Right? That's first. This another topic. Why I shared all this topic, because this is not so conventional economics title. It's a we normally in economics title we very much focus on pure economics, macroeconomics itself. Here one title on crime, one title on trade, food trade, export and import of trade. The other one is about how would mother decision to work affect childbearing. It's in Malaysia. This is about childbearing and related to women going to work. Will that impact the fertility, mortality, and related variable inside there? Right. I think this was published back in 2013, 2014, somewhere there also. Or beyond that. No, sorry, it's 2015 actually. Yeah, published 2015, and in one of the journal. And we use some of the variable. For example, this variable, female education, how it impact third year, whether we focus on career development, or or the woman actually focusing on bearing a child. This is a rather an important topic, not just for I mean, in terms of policy making, but also practicality, right? Do we want the woman just stay at home, not working, or we want that work at the same time also, of course, taking care of the family? And that kind of variable is available actually, I mean, all over each country itself, and how they actually link to childbearing, how linked to fertility, how that link to themselves, whether having high education or having a better job, will that hinder the woman actually to bear a child? And so on. These are what we are looking into, that perspective. Again, on social economics. It's rather than just pure economics analysis or data itself. Right. And this interesting study on a theory called EKC, Environmental Kuznets curve, on how industrialization, what actually impact, whether industrialization, whether environmental issues, or whether environmental impact negatively or positively in a country. In this case, this paper is about Indonesia, right? How this country is served. There's actually quite numerous studies for the country Philippines, your country, the Philippines. Maybe not. Yeah, I have it inside my I mean, not here inside the notes, but I have some of the papers related for the Philippines, where I'll share with you also, if you want to see that kind of real application of what actually been doing, or what other researchers are doing, especially using, the focus is using the method that I'm saying, but then again, adopted practically into research paper, and then the implication was vast. Right? The application is vast, not just contained into economic studies, but all the other field also. As long data is there, right? Data is there, we can do a lot of things. And to continue what our discussion, this is the fourth part itself, before we ended up our session for today. Let me go back here, some of my slides, what I've been mentioning earlier. Let me put in the concept. Here, this slide. This is what I already discussed with you, stationarity. You need to check each variable characteristic, and then co-integration. And then this is what the thing that I'm doing right now. especially whether it's VAR, ECM, VECM. This will be, we leave it for the next class, our next discussion. Then we do practicality using some data itself. I'll share with you the data if you want to do some estimation itself, or you can find your own data. You can create the project so that you can share in the class, perhaps in the last meeting next month. Let's see how we can plan for that, right? To adopt. Let me go back to the slide. So we come to the last portion here in this particular afternoon. This part itself. So this part is called causality. In a simple language, it's actually called causality. Causality means whether we want to, we are testing, or we want to know whether X cause Y, or Y cause X, or if you have more variable, then if I have more types of possibility. If 3 variable, then for example, you want to know, let's say you have another variable, Y cos Z, or X cos Z. If let's say you have more variable, you want to know their relationship or causality. Causality means that from statistical point of view, whether this variable cause the other variable. Why that is important? If you ask me, why that is very important? That is important especially for policy making. If you know that this one variable impacting another variable, then we can use this as a very important policy analysis or policy conclusion. For example, if we know that in the real scenario, if we know that government expenditure, not necessarily government expenditure actually boosts up economy, for example, expenditure boosts up expenditure of what EX, normally I represented EX. EX actually impact GDP, for example, or cause GDP. Means that an increase in this one will also increase if the relationship is causing and also positively impact. The more we spend, supposedly it will contribute to the GDP or the growth of the country, rather than we just save the money. Saving is good, but if you don't spend, the economy will not moving. It will die. It will stop. We have proved that in the time of pandemic. In the time of pandemic, especially this COVID pandemic, you've seen that we all locked down. All of us locked down in Malaysia too. Lockdown. No economic activity going on, no business going on, no flying, especially no flying. The aviation was closed. No plane is flying. Everyone is on the ground. That kills the business because no one spend, no consumption, no expenditure, and that impact badly, especially the tourism sector, the aviation sector, and related all of it. So, want to know what's the impact of it. So we can use a simple analysis called Granger causality. Again, this Granger is the Granger that I mentioned to you earlier on. He's the one who responsible for this also, right? So, but then again, this Granger causality will be in VECM. VECM is a special case of VAR, a special model of VAR. Special model of VAR, right? We've gone through this part again. Okay, so this is the arrow. After co-integration, after we test, there's a long-run relationship between the variable. Okay, good. We know that variable A, variable B, variable C, variable D having long-run relationship. Perfect. But now we want to know A cos B, B cos C, C cos D, perhaps, and so on. What kind of relationship causality that they have? We know that there's a long-run relationship already. Understand? No problem, which is good. Then after that, we want to know whether which variable causing which variable are important variable, can be used as a policy variable. When I say policy variable, means that they are the one responsible or to ensure that there's a growth in the country or a district or so on and so on. Yeah, your data can be also in the district where you come from, the district where you are in, if the data is there. And that can be very, very good. Indicate the direction of causality among the variable. VECM also allowed to distinguish between short run and long run causality. There's a long run, there's a short run causality. This is interesting. If you use VAR, most of the time we are dealing with short run rather than long run. But if you use BECM model, of course you have to fulfill certain criteria to use that model. In this case, of course, it's time series, data, co-integration exists, long-run relationship exists, then we move forward to VECM. If co-integration do not exist, then we move to VAR. This is again the concept. Not to worry much. I think I have put some part of it in the slide later on. The summary of what I'm been talking about for the past of more than 1 hour. Right. So of course, VECM is a technique being used a lot in the literature also for forecasting, to know the cyclical behavior of the economy and related. So the dynamic interaction, as I told you just now, the causality will be able to form a much more coherent policy for the economy. If you know that, right, the interaction. Now we do not stop the variable to interact. If you go beyond, previously in 1970s types of model, 1970s types of model will be like y equals to alpha plus beta x perhaps plus an error term. This is only one equation. If we have another equation of x equals to alpha plus beta y plus an error term, this is equation number 2. In 1970s, we have to test them separately. But with VAR, with VECM, we can do that together. And then we put like this in a matrix form. We estimate them 2 equation, 3 equation, 4 equation, and then we see the interaction between the variables. This interaction is what we want, especially in Granger causality. So that we know this variable caused this one, this variable caused the other one, and so on. Then this relationship perhaps will be a little bit sophisticated, but it's good for us to know, this is what happened. This is what happened. And this will be good for policy. You can easily tell the government or the whoever authorities that is it, this is what happened. This is what I found. How that been adopted into the real case, right? All right. So let me see. Let me move forward. Let me just move forward this one. All right. Okay. Next slide. Right. And of course, the Granger causality, they've been using numbers of tests like a F-test, especially to answer this, whether the variable have a Granger causality, whether the variable caused the other variable. Okay. This is from the point of view of ECT. Example like this. This is adopted again from one of my articles between the relationship between budget deficit and current account deficit. Budget deficit and current account deficit means that twin deficit, they call it in the literature of economics. Current account, if it's in deficit, normally it will impact budget.
of the country also in deficit, or the other way around also. It can happen, or both way. So that's what we want to find, whether to test the budget deficit does not grandeur cause movement in CAD, which is current account deficit. So we want to test this kind of idea. Just budget deficit cause current account to be in deficit, or the other way around, or both way, or there's no relationship. So you have two. If let's say you have two variable, you can get 4 possibility of result. 4 possibility. I just give this from the practical point of view, straight away to practical point of view. 2 variable, 4 possibility of result means that in this case will be like BD cos CAD, for example. This is one. Or you can have CAD cos BD. Oh, you can have CAD. I think I give up on this. Let me write a better one for you, for all of you here. All right. For example, like I told you just now, we can get this type of relationship, cos CAD, or we can get CAD cos BD, or we can get BD cos CAD, both way. CAD cos BD, BD cos CAD, so both way, right? And the last one is that CAD do not, right? Do not, right? Right. I just use this one. Right. They don't have relationship here. Okay. Okay, never mind. I draw back. Right. Do not have relationship. So that's a possibility of result that you can get for this relationship. If you have 2 variables, if 3 variables, the possibility of result will be more. And you have 4 variables and so on and so on. Right? Let me move forward. Okay. And let me just clear this thing off. And the next slide. Let me move to the next slide. Okay. Yeah. This is what I've been mentioning for the past nearly 1.5 hours. We have a data, raw data, time series data. And then after that, we test. Here we test stationary. This is where we test NS or non-stationary or stationary here. This part here. And only after that, after the result, what should we do? If we have I1 variable or integrated of order 1 variable or stationary in first different, and then we can move forward with this one called integration, right? If we have no co-integration, we use VAR as I mentioned just now. With co-integration, we use VECM. Right? If let's say all the variables are already in stationary, in this case means that the variable is like this all, then you can straight away use var in level, means that this is long run. This part is long run. This part is short run. This part VECM here contain both LR, which is long run, and short run. I know it's a bit right thing. Right? So long run and short run in this sense. So I know this, perhaps this concept for most of you, this might be something very alien, or something very perhaps something new. If this is not something new, it's also good. If it's something new, it is also good. You can learn from this and then can read through some of the articles that are related. Okay, let me move forward. So this is one of the software that I use a lot here in Malaysia to do some estimation using the time series data eViews 13, of course, if purchase, it will be more expensive. If not, then they can always find other alternative. If the university subscribe to it, it's good. My university, my faculty subscribe to this program, statistical program for the usage of student, staff, student and staff, right? And I think these are the few last slides actually. Can go to my channel of YouTube. We can some videos is there actually to talk about some econometrics analysis and whatnot that I mentioned. Actually, some of the videos are there. Not this recording, but some of the videos are there explaining of what is happening. I dedicated actually that particular YouTube channel for especially in the pandemic time, right? In my class, so I have that. All the videos are actually there. If you want to listen to it, some of it are related to what I said here. Some of it are beyond that. So something related that I've been mentioning here, right? With that, it's 3:30 now. I'll stop here for a while. Stop here. If you have any discussion or any question, please do ask me, because I want some, perhaps some questions so that you can, so that we can discuss further. Okay. Question, perhaps you have. Let me. Any question? Anything that you want to share? Oh, yes, you can ask. You can just put on your mic. You can ask if you have anything that concern you. I will share this thing. Any question from any one of you here? Hope everyone is doing well. I have shared the slide that I used just now inside the chat box. If you can look at it, you can download. It's free. Any question? Anything you want to know? What sort of understanding or what sort of things that you want to understand a little bit further? No?
Sir?
Yes.
What's the significance of using seasonality in eView, especially if the data is time series or a yearly data?
What's the significance of? Can you repeat the question?
Yes, of course, sir.
Yeah.
The significance of using seasonality in eViews, especially if the data is an annual data.
Okay. Thank you for that particular question. Important question, actually. Important question. Whether it's an annual data, whether it's a daily data, whether it's a monthly data, quarterly data, and related, stationarity need to be tested in the for your data. Whether it doesn't matter, as long as a time series data, you need to test the stationarity. As long as using time series data. So you need to test the stationarity of the data. Why it's important, as I mentioned earlier, is of course we want to understand the characteristic of each variable. Only then you can decide what sort of methods that is suitable, because that will decide what kind of methodology that is suitable. Are we going to proceed to co-integration, for example, or other methods to understand each variable? If you have 5 variables, for example, 5 variables that you use in the model, that you want to do some estimation, you need to test each variable individually, one by one, and to understand whether should there be in the model from the statistical point of view. Yeah, from our understanding, perhaps from your understanding, from we want to have these 5 variables. But then again, if the statistical analysis says that this one variable perhaps not suitable inside to test, then we can exclude them. So in a way, stationarity test not just a test by itself, but it's like a precondition before going to co-integration, before going to other analysis or other estimation. I hope I answer you well for that particular purpose.
Thank you, Dr. Evan.
Thank you. Any more question? You can always ask. You can drop down in the chat box if you don't want to on your mic. I hope you get some idea. You get familiar. You get familiar with. So should I ask everyone? Are you familiar with this methodology, or is it something new for everyone? Do you learn that in some other classes or in this class itself?
Not so much po, sir.
Not so much. Okay, thank you. Any more question from any of you here? You want to ask anything that is possible for you to ask? Not just listening to what I'm saying.
I just wanted to ask, sir, if we are going to tackle about panel data for the next discussion, since we just tackle about MRA, the multiple regression analysis, and the simple one on our past subjects here in our course.
So you have discussed about multiple regression in your in your class. I mean, not in this class, but not in my class here right now. So in another classes, you have talk about multiple regression, right? Is it? Am I correct?
Yes.
Okay. So today I'm talking about time series. Yes, panel. We can discuss on panel. This is actually part of my idea here. I want to bring forward for you to time series first, and then I'll bring forward some of panel analysis, panel data and understanding. Perhaps in next year January, right? In January next year, I'll talk about that. But if you have any issues, actually, this is what I have in mind, because we're going to meet up 4 times as per my understanding with your lecturer. I was given 4 slots. I was happy to have 4 slots with all of you here. Despite that, it will be much better actually if I go there or if I meet all of you face to face. It's okay, perhaps, and then next time. So this is the first one. Right, the second meetup actually next week, hopefully, next week, next Saturday, we're going to do some practical application, right? To not just to understand what is it all about, but I want to bring some practical, doing some estimation, really using eViews, right? So that's the idea here. That's next week, and I'll bring forward because when we do analysis, there will be more to discuss, more to show you. Although it's in the Zoom, or although it's online like this, I can show you what to do with the data and do some analysis. Time series, we still do time series from stationarity, from non-stationary and stationary, and then to co-integration, and then to VAR, VECM, and then we can do a little bit more of dynamic analysis, which I do not explain in the notes just now. I can do that. That will take quite some time with application. If you have eViews with you, if you don't have, you can always go to their homepage to download the student version. They have the student version, I think free for, I don't know for how long right now. They have it. Let me just show to you what I can. Let me share back my screen now because we still have time right now. Let me share back my. Yep. I think you can see my screen here. eViews. This is the homepage of eViews. eView 13 here. Accept all. Of course, this is I mean, if you buy the license and so on, everything is here. But then again, if you have this, where is it? The student version, commercial student. Student version is here. This part of it, right? This part of it. This is student version. eView university version or student version Lite is also available. Of course, if you use the student version, there's always some limitation. But it's okay. It's good enough. Student version is good enough for you to do a lot of estimation. So you can practice that. You can download and practice. And this is free. Student version is free. The rest are not free, of course. So we will focus this thing. Right? These are some of the, of course, if eView 13, they have a new version of it. This is one. Let me stop this sharing. How does eView 13 looks like? Of course, let me go back to. Let me share my screen. Yep. So this is eView 13, for example. This is in my this is in my computer. I think you'll be able to see my screen right now. This is eViews actually. This is eView 13, but it's licensed to my university. So my university actually buy this program, and then all of us, the students and all the academic staff actually can use them. So it's licensed through to ours. This is eView 13, the latest one, which I think I'll share. Not to share. I will show how to do that, especially next week. Not this week. Right. There's a lot of things to learn inside there. Interesting thing to learn. This is one of the software. Of course, others. There's a lot of other software to or other statistical software actually to use. I'm not sure what do you use. What you use actually? Do you use any of the software for statistical analysis in your class? On any of the class? Any software that you use?
Sometimes, sir, we use SPSS.
SPSS. All right. So use SPSS. Good. SPSS is I will not. I will not. Of course, I will not touch on SPSS because I'm going to use this. Most part of it I will use, or all of it I will use. eViews we call it. eViews is a short form for econometrics views, and some actually use. Oh, there's a question. Thank you. All right, that's direct towards me. All right. There's a question from Andrea. The question we would like to ask for your assistant for paper. The title is like this, like this. I'd like to know if multiple regression is the right tool to use for our variables. I need to see what is the paper is all about. I think by the end of this course, actually you need to produce some empirical result, right? For the projects or something like that. Am I correct or something? Let me just, yeah. I have a question. Let me answer this one question that directed to me. You can send me multiple regression is actually It's actually of course, multiple regression. You can use that to estimate, to do the estimation. That's to answer the question in the chat box to me by Andrea, but she directed the question to me. First of all, you must know how big is your sample. The sample itself. If you, looking into this, if your sample is from 1994 to 2020, actually you have 20 over years of data, which is quite good. You can use multiple regression. You can use, and also you can use the method that I just introduced to you. It can be done. It also can be done. All right. That's first. This the answering you that part. But if you want to show me, if you don't mind, if you want to show me after doing some estimation, if you want to show me the results, I'll be very happy to look at it or discussion in the class. Or you can always drop me an email if you want to. If I can have time to look at, I'll be very happy. In my notes just now, I think I have my email there. But then again, I just put it here. My email is there. So this is directed. Let me put to everyone. Right, this is my email. Those of you who are interested. The second question there inside the chat box by Anna. I want to know if you would also include in the future discussion on how to deal with missing value data in the time series. I'm not going to specifically focus on that part, missing data, because in time series, as per my understanding, Anna, as per my understanding, in time series, normally if we have missing data, we just do not, we would just, for example, if you have a data from if your data is from 1980 to 2022, for example, data 1980-2022, and you have 5 variables, let's say one of the variable actually have, what is this? Yeah, English, of course. If let's say one of the variable, you have 5 variable, one variable out of the 5 have, in some years have missing. Most of the time, how to deal with that, I straight away tell you how to deal with that is that either you ended up until the date that is no missing, means that the model itself should not have missing observation or missing data. All right, that's first. Or the second one that can be adopted also is that, let's say the missing data in one variable only 1 year or 2 years in the whole time series. The most, and in that regards also, first solution just now, you just stop where means that let's say the missing data for one of the variable up, the data don't have 2021, 2022 data. Okay, so your sample is only up to 2020. That's one solution. The second solution, let's say the data missing in 1990, 1 year only for one variable. In most cases, as far as I understand, as far as I know, as far as I'm doing the research for the years, that is okay to miss one for that variable. So you just let it be such a way. It might affect your result, but it will not affect that much. It will be okay for that. All right. I hope I answer you that part, Anna.
Thank you, sir.
Yeah. The next question here, time series data for forecasting future events. That's what I'm doing. That's what I'm slowly getting into that actually, Aubrey. I'm slowly getting into that from the modeling, from this understanding itself. If we do, I can do that part only if I have the program, the statistical program in front of me. Because for me to do practical is more important. Theoretical understanding, forecasting will be like, forecasting is what I mentioned earlier on in this class just now, is that it's like forecasting the weather outside right now. The weather in my place right now is sunny. It's very sunny outside there right now. Like a weather forecasting, like I mentioned just now in our apps, in our application, in any handphone today, you have a weather forecast out there. So that will be a good practice. We can do that if we have the application or the statistical application. I will use that. I can include that part inside next week or perhaps the week in our next meeting on doing some forecasting analysis. No problem. It's no problem. I'm going into there. Thank you for the question, Aubrey.
Thank you, Pastor.
Any more question that you want to ask? We are at 3:51 in the afternoon here. I think Malaysia and the Philippines having the same time, I guess. Same time zone, I guess. Oh, all right. Aha. Kylie, if I pronounce your name correctly, direct message to me. We also include how to deal with survey and tests to be conducted along with the future discussion. Now, survey data or means that questionnaire, data using questionnaire will not be a part of what I'm sharing. I'm going to focus on time series and perhaps and panel if we have more time of it, right? The full lecture that I have. I'm not going to do survey data. I think survey data will be conducted by your the other instructor, the lecturer itself, your lecturer itself. Me, I will focusing on time series. I've told your instructor that I'm focusing on time series itself, the practical of it. If we can do some analysis based on data from the Philippines, even better, right? Or you kind of want to show me some of your result from the analysis, even better. We can discuss that in our last meeting in January next year, of course. So that will be more meaningful. Theory must have practical. No, if just theory, understanding, giving up lecture like this without some practical for me, the class will be less meaningful. With more meaningful, we can apply some other ideas. That's what I can tell you right now. So no, I'm not focusing on survey. That will be some others. If I put on survey, put on this one, there will be more different focus. My focus is on time series panel itself. All right. I hope I answer you that part. Any more question from any one of you here? You can open up your mic or actually you can also put up in the chat box, let's say. Okay. There's 60 plus of you here. Good. Are you all in your second year, third year of your study?
Fourth year, sir.
Third year. All right. Fourth year. Oh, you're in your final year. Wow, good. Perfect. This is your final year. So you're going to graduate very soon. Oh, good. That's why you do some projects. Oh, that'll be good, right? Yeah. I put my email there. Let's say if you have something they want to ask me, some extra thing, especially related to time series and panel data, I'll be happy to help if I can. All right. Any more question? Oh, wow. I just see my phone. I have one LinkedIn connection already from one of you here. Interesting. LinkedIn. I'm in LinkedIn also, by the way. Right. Okay. Any last question I can take? We have last perhaps 5 minutes for this. Supposedly, I have up to 4 o'clock. If you have any last question, I'll be very happy to answer before we sign off for today. Any question? Any further question or anything that you want to share? Let me see what I have inside here. Let me. Let me share with you one of the article that I found quite recently. I think it's by your. Can have a look of this article before we go off for today. Let me just share this thing. Oh, maybe you cannot see my screen here. I share back. Right, I just sent another paper to the chat box actually. How to make it bigger for the last few minutes of us here. Right, I think the whole screen. Okay, this paper actually I think it's written by one of your lecturer in your university. Is using the method that I'm mentioning just now, VECM. But the group itself adopted ARDL, which is another method for integration actually, which can be easily show if I do the practical in eViews perhaps next week. I can do that also. How actually the numbers of methodology can be done if you want to understand that part. All right. Okay. This is one of the article I just put in the chat box for you to look at it. Oh, sorry, I sent to direct. It's supposed to be for all sometimes. Right, put it back into the chat box. Let's say you are interested to download. Of course, you can do so. If not, then it'll be interesting. Any more last question? I've been waiting for the last question if you have any. There's about 69 of you here. Oh. So I get more notification from LinkedIn right now to connect. I guess it's from most of you here. two LinkedIn connection. Wow, this is good. Can connect me through LinkedIn. I have my LinkedIn. I have the YouTube as I mentioned just now, and I also have of course Facebook and all the remaining. No, I don't have X yet. Anyhow, yeah, it's nearly 4. I pass back to you, Nori. Thank you for having me here this afternoon. I'm very happy to see this. So, and let's meet up again next week.
Thank you, sir. Sir, before we wrap things up, can we have a photo opportunity?
Yes, of course. Please. Can everyone on their camera so that we can have one nice picture taken? So everyone, so that I know that I'm not talking to the screen only.
Thank you, Dr. Ivan.
Thank you.
Thank you for your time, sir.
No problem.
Sir, I'll be processing your BIR. I want you to process the documents. No, sir, you need to sign. Then I'll be the one processing it in our HR department, sir.
Yeah,
Thank
I
you,
told.
sir. Yeah, no problem, sir. Sir, because we will have a long-term engagement, sir. I hope that we'll have a long-term engagement.
Yeah, I am.
especially-
Mm.
Yeah, sir.
I want to go there one day. I want to go to
Yes, sir. We
PUP.
can. Yes, sir. We can do that, sir. So instead of you said that you will not get the the honorarium, so you can use that as your in buying tickets, so that you will not pay anything, no, and then accommodate you here. So we can arrange that one, sir, if you want.
Okay. They'll be good.
Yeah, sir. So
Okay.
you need to sign the document so that I can process that in our HR department.
All right. I'll do that.
Okay, sir.
Okay.
Okay, sir.
Okay.
Gilmore?
Okay, for the first slide, 1, 2, 3, smile. Next slide, 1, 2, 3, smile. Last one, 1, 2, 3, smile. Thank you, sir.
Thank you for having me.
Yes, sir. Thank you very much, sir.
Yeah, I'll see you again, all of you, next week.
Yes, sir. Next week again, sir. Thank you, sir.
Yeah, bye-bye.
Bye-bye po.
Thank you, sir.
Thank you so much, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you po.
Georgie.
Yes
Hello?
po, ma'am.
Turn off muna. Ikaw na yung host, right?
Apo.
Thank you for the
Sige po.
assistance.
Thank
Thank
you
you for
po.
the assistance kasi I have my class kani. Thank you, Georgie.
Thank you po.
Okay, bye-bye. Kindly end na lang.